Hello class. Welcome back. I decided to also start teaching chemistry. One of the reasons is because the Chinese periodic table is so easy. Here's an example. This means beryllium. Try to do an analysis yourself. Feel free to pause the video here and give it a shot. To you people who did not manage to figure the meaning out, here's the character explained. First of all, this is the radical, gold. But because we know gold is also a metal, so in this context, this means metal. More specifically, an alkaline earth metal. As we can see, the Chinese can just look at the radical and know what kind of element it is. While we English speakers have to memorize them and we have no help whatsoever except some common sense. Such as lithium should be a metal, iron, nickel, and gold too, and oxygen is a gas. But can any of you name what gallium is? Or dysprosium? Seriously, why must English have no helping hands whatsoever? Pants. Anyways, let's talk about what's here on the side. This means shell or outer layer. Most of the time it means outer layer. And beryllium is most of the time used in defense, such as a missile uses some beryllium for its shell. And aircraft is armor. So it makes sense for beryllium to be the defense of the alkaline earth metals. It can also be the sound, like in, is pronounced jing, which is similar to, or ching. Or sometimes even both. Isn't that convenient? Unlike English. Anyways, here's Chinese's periodic table radicals if you wanted to know. Of course, man-made elements have exclusive words. So you can use Google Translate for those. But general rule of thumb, just memorize this board and it will make your job easier. Now, on to actual chemistry. Ah yes, the first element of the periodic table. Hydrogen. It is the simplest element in the universe, consisting of only one proton and one electron. Hydrogen makes up 75% of all matter in the universe. It is because it was the simplest element formed in the Big Bang, and helium is only sitting at 23%. The other 2% are all the other elements that are the universe's baryonic, or normal, matter. This is only one of the hydrogens that exist. Yes, different hydrogens exist with variations, such as maybe a neutron, which we'll get to later, or maybe some more electrons. The variant I am showing you is called protium, the most stable kind of hydrogen, making up 99.98% of all occurring hydrogens. It feels weird to add a plural to hydrogen. protium's half-life lasts about 10 to the power of 33 years. Or 1 followed by 33 zeros. But protium also has a buddy to share the stable seat with, deuterium. This is deuterium. As you can see, there's a neutron. You may be wondering why there is an N. Well, that's a neutron. Neutrons are literally neutral. They have no charge whatsoever. But here's a cool fact, deuterium is so stable that it can never decay. It is stable and has existed since the Big Bang. And then we have tritium. This is tritium. And
warning, unstable isotope detected. Highly flammable. Proceed with caution. Warning, unstable isotope detected. Highly flammable. Proceed with caution. Warning, unstable isotope detected. Highly flammable. Proceed
this is
with
tritium.
caution.
It has 2 neutrons,
Unstable
1
isotope
proton and
detected.
1 electron.
Highly flammable. Proceed with caution. Warning, unstable isotope detected.
It is very unstable and has a half-life of 12.32 years.
Unstable isotope detected. Highly flammable. Proceed
Do not play with items. It is very
unstable isotope detected. Highly flammable. Proceed with caution.
Oopsie. That was horrifying. Anyways. At room temperature, hydrogen is a colorless, odorless, non-toxic, and highly flammable gas. Basically it's the same thing as silent but can catch you on fire deadly. Hydrogen can exhibit +1 by losing its electron, or -1 by gaining an electron, oxidation states. Also, hydrogen is really important for farms. More specifically, it helps create ammonia, NH3 or 3 hydrogens and 1 nitrogen. And ammonia is a fundamental tool to create fertilization. Wait, no, fertilization? How do I spell that? Fertilization, fertilization. So that's how you spell it. Ah, balloons. Everybody loves balloons. They float. They can statically charge your hair. And they can also pop. But have you ever wondered what makes a balloon float up? Well, it's all done thanks to the amazing element of helium. Helium is the second element of the periodic table. It has an atomic mass of 4.0026 AMU, which is about 4 times as heavier than hydrogen, with only an atomic mass of 1.008 AMU. Also, AMU means atomic mass unit, a tiny unit for measuring atoms and molecules, defined as 1/12 the mass of a carbon-12 atom. Helium is a colorless, odorless, tasteless, inert, unreactive, monatomic gas, belonging to the noble gases. Basically hydrogen 2O. because helium is lighter than air, which is composed of mostly oxygen and nitrogen, which weigh 16.00 amu and 14.01 amu respectively. Helium has 2 protons and 2 neutrons and 2 electrons. Seems like it's a fan of the number 2. It has a full electron shell. This means an atom's valence shell is completely filled with electrons. It also has isotopes. Some are unstable, such as helium-6, 6He, and helium-8, 8He. Helium-6, 6He, has 2 protons and 4 neutrons. Helium-8, 8He, has 2 protons and 6 neutrons. Notice anything? Helium-6, 6He, and helium-8, 8He, both keep the same number of protons. But the neutron count is different. Moreover, 2 plus 4 equals 6, so helium-6 is really saying 2 protons and 4 neutrons. Same with helium-8. What a breakthrough! A valence shell is the biggest ring of electrons you'll see. For instance, helium's valence shell is this one the arrow is pointing towards. Shells fill from the inside out. So the valence shell being filled means all other shells inside the valence shell have been maxed out. Because helium is a noble gas, it nobly stays inert. No crazy radiation, no everything on fire. Just peace. BR. Anyways, helium and its buddy hydrogen make up 98 to 99.99% of the Sun. Also, like hydrogen, it's because hydrogen and helium were the 2 most abundant atoms in the early universe. Lastly, we have lithium. Lithium is essential in our modern lives. Lithium batteries in your phone, your toys, literally anything with a battery. Lithium is also our first alkali metal. Lithium is also the lightest general metal, in fact. It's so light that it can float on water. But before you put your lithium batteries in water, heed this warning. It is extremely dangerous to put lithium in water, as alkali metals react very aggressively with H2O and can lead to some explosive events. Anyways, lithium has 3 protons, 4 neutrons and 3 electrons. Like all other elements, it also has isotopes. It's found in rocks, and is used in batteries, alloys, ceramics, and even medicine. Also, it has strong tendency to lose its single valence electron, forming A+1 ion. This is the first element to do so that we have covered. You might wonder why lithium wants to lose an electron. It's because it's much easier than gaining 7, allowing it to achieve a stable, full inner electron shell like the noble gaze. Atoms like to take the easy way out, and it just so happens that giving is easier than gaining. So lithium desperately wants to sell its electron to some random passerby who does want an electron, such as fluorine. Then, this forms a positive lithium ion, Li+, because an electron is a minus, so losing a minus means adding. If you learn math, you should know this. Atoms strive for full outer electron shells for stability, and lithium's single valence electron. It's stopping lithium from achieving peace. Phew. That was a lot to unpack. I hope you learned something new. Optional stuff for you to do. Search about shells and the octet rule. That's it. Goodbye. Driving in my car right after A